Hello all and welcome to the AI Cloud and Modern Workplace Conference 2024. We are delighted to have you here and hope you enjoy all these amazing online events. We have a very exciting agenda for you all these 3 days with speakers from different backgrounds and perspectives who will share their insights, experience on how AI and cloud computing is transforming the way we work and we live. But before we dive into the next session, we have a very, very special guest um, uh, who who will share his insight on how to create a stable Azure solution using only the cheapest tiers. This is the story of an Azure architecture that was designed to consume 100 requests per hour. Then the requirements changed, and we had to consume 1,000 requests per minute, while the budget remained the same. In the session, he will show you the tricks he used to go around the various limitations of Azure cheapest tiers of Azure Function, Logic App, Azure Data Factory, and Azure Services Bus, and others. Let me say a few things about the next speaker, who is an excellent professional. I met him 3 or 4 years ago. I don't remember, and I remember that he is always a positive mind. He's an excellent professional with experience and contribution to the community. I asked him to join the MVP program because he very well deserved to be an MVP, and I think that he's a candidate MVP now. His mastermind in the field of Azure, and Nikos has a great selfless contribution to the community with many presentations across the globe, and is a very active member with great articles. I have the great pleasure and honor to present you Nikos Delis, Senior Cloud Engineer and Cloud Evangelist at Hello Sweden. Nico, you honored us with your presence here today. You honored us with your presence to all of our summits. You are here and you support us, and you accept every time that you ask you to present for us. I would like to express my immense appreciation for your presence, and I'm expecting to see your very, very, very interesting presentation. I would like to inform you before the presentation that I will steal all your architectural method because I need it.
Thanks for having me, and thanks for your very nice words, Kostadina. I'm always happy to attend your sessions, and being a part of them is like beyond my wildest expectations. So it's me who should thank you.
So if you want to share your screen to pass it in the main stage, yes, perfect.
Thank you. Okay, I am ready to start.
Yes, you are ready. Based on a true story. We want to hear this true story.
It is based on a true story. No, I know that it's 5 o'clock. If I'm not right, if I'm right in Greece, right?
Yes.
Okay. Now I'll tell you about my background, but it's 4 o'clock where I am now, and I imagine that you have seen a lot of fantastic sessions. I said earlier to you, Konstantinos, I don't know how you managed to collect all those experts in this event, and I believe that the attendees have been blessed with the opportunity of watching all of them. And I understand that the cognitive load has been quite heavy, and I want to entertain you a little bit with my story. Of course, we will get technical, not very deep, but I think that everybody will have the chance to understand what I'm talking about. So the story I'm going to tell you is based on a true story. I would be more than happy to tell you the real story, but I'm afraid that it's protected by NDAs, and then there were more people included, and I don't want to hurt anybody or to say something that would make someone sad. So let's say that I have altered a little bit, or quite much, many details to protect people and protect the story, but still to let you understand what I'm talking about. So the session is called, they challenged me to create a stable Azure solution using only the cheapest tiers, and that's exactly what they did. Now, before going into the depths of the session, let me tell you a few words about me. My name is Nikos Delis. I work as a senior cloud engineer and cloud evangelist at Helo, at a company in Sweden. Now, as my name already tells you, I'm Greek. I'm born and raised in Greece, and I moved to Sweden. It's been 11 years ago, I think. Yeah. And I've been working ever since. I started as a .NET developer, and then I moved more to the more architectural side of the work, and I have been focusing on Microsoft Azure for the past 6 years about. And as you can see, I take a lot of pride in certifying my skills. This helps me a lot as a consultant and as an engineer. I also have a blog called ndtechnique.com, where I blog about things that fall within my interests. And I also write sometimes about less technical things. It might be interesting to take a look. I also have a podcast, as you can see here. It's called Azure Triumphs, and as the name probably recommends, I am talking with people who are experts in that field or in the whole Microsoft universe, and they have interesting projects to talk about or interesting stories. And last but not least, about my profile, I have had the joy to become a member of the organizers crew of the Azure Skåne community. And Skåne is the southern region of Sweden. We're together with the other organizers. We do some nice events. They are in person, but they are also streamed, and we meet once a month. So if I have anybody interested in those things, then please drop me a line, and I would be more than happy to tell you more about it. Then, of course, you can find me on X, LinkedIn, and GitHub using just my name. I think I'll be the first one to be in your list there. So now it's time to get into the story. And the story started with me being a fresh consultant in a fresh company. And it all started when I got hired. Not hired at the company. I had been at the company for a while. I mean, my employer. But I was appointed on this new assignment as an architect. And the instructions I had was that the last architect, the one that I succeeded, would start on a new assignment, and my goal for that project was to fix the little issues that were there and to expand the team if possible. The team consisted of one architect, one developer, and one project manager by then. So we wanted to have maybe 2 architects and maybe 2 or 3 developers. So my employer saw this assignment as a chance of expanding our work with them. Now, we have a saying in Greek. I don't know if we have many Greek attendees, so all of you would recognize it, but for the others, I will just explain it. It said, "Η καλή μέρα από το πρωί φαίνεται." And this means that you will know already from morning if it's going to be a good day. Now, that morning, I had arrived at the client for the first time, and I had the sales guy with me, and we were about to meet the CTO, which had misunderstood the meeting invitation, and he thought that we would meet online. Now, instead, we would meet in person, but they hadn't booked a room, so they met us in front of the door of the client because they didn't have any conference rooms available. So I was very happy to meet them, and I was very optimistic, and I shake their hand, and I told them that I am very happy to be here. And they're like, yeah. Now, so that you know, we're about to de-escalate the project. We're about to fire your team, and we just want you to fix the rest of the issues until we can go over to our next vendor. My reaction, of course, was this: like, what? What are you telling me? I was here to expand the team. I was here to make the business bigger. And now you're telling me that we have to decrease the business and we have to dismantle the team and maybe bury the project? Well, that's not the situation you want to be, but I still have my weapons. I still have like my magic recipe, which I apply in pretty much every assignment. And it goes on the soft values, which in my opinion are very, very important. So the central goal, the one that I always want to do, is to build trust. I want the client to trust that I can design a good solution for them, that I can understand their problems, I have full respect for them, and I want us to work together and have a nice time. Then one thing that has always worked for me very well is to under-promise and over-deliver. And by that I mean that if the client asks, like, is that thing possible? And I know for sure that the thing is possible, then I don't boast about it and say, yeah, of course I can do it, like it would take 5 minutes. Then instead I under-promise and say, well, let me take a look on that. I am quite positive that it should be possible. What let me think. And then when I do manage to deliver, I try to deliver a little bit more than what they asked in the beginning. So in that way, they start to trust at least my skills, and they also trust my word. So if I tell them that something is possible, then most of the times I do manage to deliver it. Then being humble cannot be overestimated. There are always people who know more than us, and maybe we know something also, but being not humble has never helped anyone. And then I will talk about money and costs a little bit later, but I want you to keep in mind that everybody wants to save money, but what they want even more is for the money they spend to create value. They want to see that they don't waste money. Nobody likes to waste money, but everybody likes to invest money. And of course, clients are paying for expertise. So it's not a school. You're not there to learn all things. But of course, every solution is unique and you have to try a lot of solutions. So feel free to try, but you really need to fail fast. And when you fail, then explain to the client why you tried what you tried and why it didn't work or why it did work. So getting now, having these weapons with me, let's try to explain you the data flow. So let's say that we have this company, and of course, in the real project, we didn't have a dairy producer. It had nothing to do like that, but the process is pretty much the same. So I'm happy to present to you the wow cow data flow, as I like to call it, jokingly, of course, but let's see the details of that. So let's say that we have a dairy producer called Wow Cow, and they produce milk and they produce cheese and they do butter and yogurt and all the dairy products that we all know. Now they send those products to the supermarkets, which we also know, all of us, and the products are sold there. So the dairy producer does not sell their products by themselves. You can go to the dairy producer yourself and buy milk. You go to the supermarket. And then the supermarkets, they know their needs. So they know that they will need like 50 cartons of milk today, and they will need maybe 20 pieces of cheese tomorrow and stuff like that. And so they make orders. They see what they sold and they see what is left, and they send orders. And those orders are going from a web portal via Microsoft Azure to the dairy producer. And then after this is done, then the dairy producer has automated procedures to invoice the supermarkets. So this is the data flow. The markets send the orders to Azure, the dairy producer gets the orders from Azure, and then they produce all those dairy products and send them back. And also the invoices are automatically sent to the markets. And I say, okay, now, I mean, even as a usual citizen, I could imagine that the data flow would be something like that. I mean, of course, I don't work for a dairy producer. I've never done that, but I could imagine that it would be something like that. And I was wondering what could go wrong, like what could be the issue. And upon asking this question, I saw that the color left their faces, and they became sad, and they started like exaggerating maybe a little bit, but they started explaining that the logs are fuzzy. I mean, okay, we have some logs, but they don't tell the story. They don't reveal what the problem is. Then we have a very serious problem of orders disappearing. It's not okay that orders disappear. When orders disappear, then we fail our clients. We cannot produce what they want. then we have a very bad user experience. The people who are sending the orders have to wait for a long time, and then they are not very technical, and they don't understand that they sometimes we have to wait. So they just push the submit button again and again, and they send the orders again and again, and we get doubles and stuff like that, which means that our personnel in the dairy producer need to take a deeper look in the orders to identify the duplicates, remove them so that they don't send invoices that are more expensive than what they should be. And this sometimes leads to delays in invoicing, and this is the worst because the markets are very careful about their budget, and of course the dairy producer wants to get paid. So invoicing is the most sensitive part of the process. This cannot fail. And then the most serious problem, or the problem that was the game changer for them, was that everything stuck during the rush hours. Now, as I mentioned in the beginning, I live in Sweden, and the big supermarkets here open at 7 o'clock in the morning, 7 a.m., and they close at 11 p.m., like 11 in the night. Now, this is or 10 p.m., but yeah, something between that. So this is quite late. They want to go home to their families, and having to wait for the system to work is a very, very bad thing that they really want to avoid. So now we know what the flow looks like. We know what the issues are. So I tell them, okay, let me take a look at the Azure, at the architecture. What does it look like? And they present me this. Now I will let that sink for a second or two. So let's take a deeper look. We have on this side the market in the green box. In the middle, in the blue box, we have a Microsoft Azure. And in the purple box, we have the data center, because the dairy producer also had their own data center because they are a very old company. They have been around forever, and of course they know their data. So they had an SQL server there, they had the CRM system, and they also had a file system. And now the main issue is here in Azure. And please take a look on this little sign here. This is a distilled version of the architecture. So there was way more than that. Now, if we start from the left side, we have the clients here in the markets who are using a portal, and they send their requests, they send their orders. They send it to an Azure resource called API management. I don't know how familiar you are with that, but let's say that it is an API wrapper, which is used as a front in Azure. It's the first resource that the requests meet, and it channels every request to the correct resource. And for some reason, they used logic apps. Now, logic apps are a low-code solution, meaning that you don't need to have developer skills, but you can build solutions that sometimes are very sophisticated, like those. Like it's like building Lego. You put the parts together, and you have a working solution. And then they were contacting each other, and they were contacting some Azure functions, and then many of them were sending data to application insights. There was also an Azure storage account somewhere there, some SQL databases that were abused, and of course we had key vaults and everything. So security-wise, it was relatively solid. In many cases, it was an overkill, I have to say, but it was quite okay. Then the gate between Azure and the data center was an Azure Data Factory. And the Data Factory is also a solution that has a data input and data output, or it has multiple inputs and multiple outputs, but this is the reason of its existence. Now, the common denominator you see here is the low-code applications that the previous architects tried to deploy solutions that did not demand developer skills. And this is where I start to have disagreements on. Now, when the standing architect described the solution to me, they told me that this is a dumpster fire, and I understand what you would think, that it burns in some places. Now, let's see where it burns. So it bears there and 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 there, and we have money leaving us, and we have our customers waiting for long times, and they wait for long times because it takes forever for this circle to happen. And for some reason, the clients that sent an order had to wait for everything to go through, for the data to land in the data center, for the invoice to be sent, and then their request was complete. So as you can see, there are many things that didn't work very well. But the one thing that was very easy to identify was that we have long queues, or exactly when we had the rush hour, and the rush hour means that many supermarkets are sending a lot of orders away. So the queues get longer and longer and longer. And why does this happen? I start to identify the problems. So the first problem I found is that the logic apps use connectors to connect to speak to the other services, and those connectors have limitations. Now, especially the most interesting one is the one between between the logic app and the data factory, and this the connector there can only serve 100 requests per minute. And it means that the first 100 orders you get, they will go through like immediately in milliseconds. But then for the rest of the minute, not a single order will go through. But we will have a queue building. Then since we have a queue, we are going to have upscaling. So we're going to have more instances. And then they're also going to use the same connector, meaning if you share your pizza with others, then it's less pizza for you. And we don't even get those 100 because each instance is going to get some of those 100. And this happens because we use the cheapest tiers on everything. And why did they pick the cheapest tiers of everything? Well, because somebody told them that Azure is free and that they should use cloud because it's free. Now, let's not get into that. Of course, this is wrong, but there's no way that this can be saved now. So we still have to use low budget. And then the API management, and this is the OPIM, the API management. For some reason, it waited for the whole cycle to complete. Now, this is unnecessary, actually. And we also had a lot of unnecessary DB interaction. We were asking for client details again and again and again for every request. Obviously, using the lowest tiers and being on the consumption tier for Azure Functions, we have limited to no actually scale options. So we cannot decide if we want to have more instances of something on a certain hour to predict that more orders are coming or orders have to be served. And then the low-code stuff, I understand that they wanted to produce, the architects to build solutions fast, and then you can do a logic app in a few hours, while a real function solution would take maybe a week or two. But this is, in my eyes, this was not a suitable solution for this project. So I understand that I am leading you to the conclusion that everything would be solved if we just kill the logic apps. Now, maybe, but one more thing. When I'm about to serve them with a solution that excludes the logic app or that replaces the logic apps with functions, they tell me that the front-end team has found a solution. And the solution is that instead of using one order with multiple items, like that this big supermarket is sending us one order with 50 liters of milk and 100 kilos of cheese and 100 kilos of yogurt and so on and so forth. They are going to send one order with one item. And I'm like, why is this going to solve the problem? And they tell me that, well, we have worked for months and we have observed that smaller orders take a lower time. Now, technically, this might be the truth, but the reason why this is because the smaller orders come from the smaller markets, and the smaller markets don't close at 10 p.m. and 11 p.m., so they are not in the rush hour. And since we have no traffic, we have no queues, and then everything goes fast. So I'm telling them, believe in guys, this is not going to help. And they say, well, we have been working with that for 6 months, and now it's deployed, now that's it. And the result is that we got 40 times the traffic we had before. So a difference between one order with 40 items and one order with one item is like from 5 kilobytes to 4 kilobytes. So like nothing. But 2,000 orders per day to 80,000 orders, but small orders, of course, per day makes a huge difference. And to which the reaction was, no, this solves nothing. We have to start fixing problems. We have to start understanding where to start. So I said, okay, let's go back to the soft skills. I have to pick first the things that take the lowest effort, but they will make the biggest difference. So low effort, high impacts. So what can we do? They complain a lot about the logs being useless, being fuzzy. Why is that? Well, because they log pretty much everything, every single request, every single dependency, every single trace. Now, if you have worked with Azure Functions, I'm sure you relate. The functions themselves, they produce a lot of logs, and we don't really have to use them for troubleshooting unless something is really wrong. We most want to rely on our own logs, the logs that we build. So if I fix that, then they would probably start trusting the logs a little bit more. This would bring them awareness. They would be able to understand what is wrong with an order without having to call me or my team and paying for our time. Then in the beginning of the architecture, I showed you that the market guys were sending orders and they would have to wait for the whole process to be done before they got a confirmation that their order is processed. Now, this is useless. We have to apply the separation of concerns and we have to apply the single responsibility. So their only responsibility, the market guy's only responsibility is that they send an order that is valid, that they have filled all the necessary details. We have the customer details, we have the address where they're going to send the delivery products. They have to send correct amounts, they have to put the discounts in a correct way. But all of that can be checked in the very beginning. We don't have to wait for the whole thing to go through. Their only job is to send a good order. So the moment they do, we are done. So if I would to fix the validation, then that would fix immediately the user experience, and that would give me a lot of positive energy. Then obviously the architecture, it was like 8-9 years old. It was impossible to continue on that way, and it had to be untangled and simplified. And then those low code resources, they never worked in the way they wanted. They never would. At least I didn't have the experience and the skills, if you may, to make them work and to support this volume. And about these needless DB interactions, we have to start caching things. And caching, if someone is not familiar, refers to saving some information in a very fast memory that we can access faster, and we can access it in a more frequent way than we do with a database. So if we take it from the beginning, how do we validate and then fire and forget? So this is the first part of the new architecture, the one that I proposed and we implemented. So again, we changed nothing here. You send your 40,000 orders to OPIM, to API management, and no, this can take a lot. This was built and managed from a different team. It was in the premium tiers. It could handle all the traffic in the world. So we send the order to an Azure function, which only purpose is to validate it. If the order is invalid, then tell them directly what's wrong. If it is valid, then you just kick off the orchestration, and I will explain you right now. and then send the logs to application insights. So that's it. This should take milliseconds. Now, a few words about the orchestration. I introduced to them the durable functions, which is an extension of the usual functions, and it solves the problem of functions having short timeouts, like 60 seconds. Sometimes we have things taking a bit longer time, and the durable functions give us opportunity to handle them using orchestrations. So this one fires again and again and again, and it runs its whole body in its execution, but every time it means an asynchronous function or a variable assertion, it will wait until the value until the variable gets its value, and it will sleep. So we don't pay for the execution. Then the moment the value comes, it will rerun everything, and it will stop in the next value setting. So easy as that. So after that, let's see what exactly the orchestration does. The orchestration has three jobs to do. First of all, it needs to gather the data. So it calls an activity function, this one, which is like a usual function, the one that everybody uses, to gather the data from the SQL database. Then after the data has come, we have to use the next function, which sends a message to service bus. Now, I will tell you a little bit more about service bus. Now, once the message is sent, we can go to the last one, and this one will create an invoice, and it will save it in a storage account. Now, of course, there is more happening, and I don't really show you all the functions and all the stuff in this architecture, but I believe that you get the spirit of it. Then you see a chain back here, and the reason of it is because this way of executing functions, like the one after the other and the one bit depending on the other, is called function chaining. Now, there is also the fan out, fan in model, where you don't have the chain and all those are fired simultaneously, and the orchestration is considered to be done when all of them have been completed. So for this particular scenario, I needed each function to wait on each other. So if we were stuck here, then of course I don't want to send any message or an invoice. And if we were here, then of course I won't send an invoice. Now, if for some reason any of those fail, then the orchestration is characterized as failed, and the dairy producers team is going to look on it and see why it failed. Now, before going on, a few words about the service bus. Service bus is one of my favorite resources. I really, really like it, and it is used to decouple microservices or workloads. So in this case, I don't really mind when these processes happen, when this function manages to speak with a data center and this with that and this with that. I just want it to happen. So sending a message to the service bus means that sometime those functions are going to make sure that the data goes where it should go. So now about some code and how we make logging make sense. So using the iLogger, which is the default one, and it is integrated with application insights, we can use custom properties. Now, I see many people not really using them, but they are very easy and they come in handy because they are very well handled by the application insights. And as you can see here, I can use my custom property. You see this custom prop order ID, which I declared here in the scope. And I can see also all the values of it. So every time a customer calls telling me I can't find the invoice for the order 1, 2, 3, 4, 5, then you just have to pick this custom property here, and to enter the value, you have fantastic user experience there, and then logging in a better way, you can see only the things that are interesting for you. You don't have to see, as you can see, all those are warnings. Now, I made them to come up in a nice way, but filtering on these custom properties, you won't see all the other needless, noisy stuff. And then we have the tiers. Now, being sure that I will rely on Azure Functions, I asked them for the B2 tier, the basic 2, which could guarantee no cold starts, meaning that nobody would have to wait for a few seconds when they were the first after a while. And it would give me predictable costs, which we really, really want, right? Then I also really wanted to have the premium tier of the service bus because the standard tier may have some latency sometimes. It might not have very high availability, so I really wanted those stuff. But they told me, no, 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 the budget has to remain the same. You can't increase it at all, even if the volume just suddenly got bigger. Now, this means that I still have to use the cheap things, which leads to a few weak links. Now, if we take them from the beginning, remember I told you that API management can handle all the traffic in the world, no problem. Well, this one can't. This is still on the consumption tier, so this might get busy. This might say to API management that, you know what, I can't do anymore. You have to wait, even if it takes milliseconds. When they start to send 10,000 orders per minute or 1,000 orders per minute, then this might get exhausted. Then that one, the activity function that is talking to the SQL server, it is talking to the server way too often. Like, why do you have to ask for the same data that never changes all the time? And since the service bus is on the standard tier, which costs like 7 Swedish crowns, while the premium tier costs 700 crowns, then this means that it will be unavailable sometimes. And what can we do? Like, it could be unavailable for more than a minute. Okay, let's take them one at a time. First of all, this one. Let's implement some retry logic. So you see, it's a simple solution. It's not like rocket science, and not everything has to be rocket science. If it fails, then try again. Okay, but if it failed because there were quite a lot of them. So how am I going to solve this? Well, you will try again, and let's explain the arguments here. You'll try again 5 times. The first time, you're going to wait for 3 seconds. The second time, you will add this delta here, 3. So 3 seconds, we start here. We wait 3 seconds, then we wait 6 seconds, then wait 9 seconds. It's like the Fibonacci scale. And you are going to increase the wait time between each requests by 3 seconds until you reach 15 seconds. So this is just empirical. It was calculated by trial and error. I just tried a few things, and this was the soft balance. Like at most I had to wait like 13, 14 seconds. So I gave it 1 extra for the edge cases. So this is done. We can handle that. Then the one with the service bus. Again, exactly the same logic, but this time, since the service bus can be unreachable for a couple of minutes at the worst scenarios, we will have to make 20 attempts. And the first retry will happen after 5 seconds, and we will increase by 3. So 5 seconds, then 8 seconds, then 11 seconds, until we reach 1 minute. So once again, this one is just from experience. I know that 20 seconds is enough. Now, keep in mind that it's not this one that is going to be alive for all those tries. It's the orchestration's responsibility to retry this one if it fails. So we'll have one last thing, the chatty function, which talks way too often with the SQL database. The solution there was given by pure code, pure C#. So instead of asking the database every single time, use cache memory, and in my case, use Redis. So use Redis to find what I was looking for in that case, maybe get the customer details. Do I have it in Redis? So I start there, try to get it from Redis. Did I have anything there? If no, then okay, then this time I will actually go to the database. If yes, then I will just use the one I have. And if I didn't have it and I get it from the database, then I will have to save it in Redis for the next iteration. So after those improvements, we had some results. And I don't want you to be impressed by the numbers, but of course numbers matter. So let's take a look. We have 2.5 million process requests per month. We had 1 million brokered messages per month. We had 150,000 cache hits per month. And those 150,000 cache hits means that 150,000 times we didn't ask the database for something. Now, all those things costs just 5,000 Swedish crowns per month. This is like 500 euros approximately, just for the Azure functions and the service bus. We don't need no logic apps. All of them were gone. No data factory. We don't need that. We can do everything with code. And we have 0 lost orders, 0 missed invoices, and 0 negativity. And of course, we had 0-ish manual interventions. Now, of course, we cannot guarantee that nothing can go wrong, but we can guarantee that the things that will go wrong will be logged in a good way that you can understand, and they will be managed at the end. So from this project, of course, what I describe you is not a pleasant experience, at least in the beginning, but every opportunity is a good one, and we learn something. So the technical lessons I learned from this project is, first of all, that the logic apps are fantastic. They really are. You can be very productive with them, but they have limitations, and you have to be aware of those. Otherwise, things will start get slow for some reason, and it won't be very apparent why. Like they will just get slow. They won't throw errors. They won't say anything. They will just begin waiting sometimes. Then the durable functions are also a fantastic tool, and they solve many problems, but they also have to be configured. We have the max concurrency on orchestrations and on activity functions. So if you don't limit them, then you might get a very expensive solution. And if you use the default limits, then maybe it won't be scalable enough. Then Redis is a lifesaver. It really is. Like it makes everything so much simpler, and you can do it for free if you implement it in an app service or something, or you can use the managed one, which is very cheap. Now we had the managed one, and I always take the managed solution if I don't want to manage something myself. And it was managed by another team also, so it didn't hurt my budget. And then I really learned that low code is high maintenance sometimes, and this was one of those times, and that you should really exhaust your app service plans. Now, every function, every web app needs the app service plan, and it is the hardware part, and it is also what we pay for. So if you do pay for it, then make sure to use all of it. And I also learned some non-technical lessons. And the most important one maybe was that stable does not have to mean unbreakable. And even angry customers can get much more understanding when they have to handle errors very seldom. And when you explain them that, well, for the budget we have, we can get like 99.9% accuracy. Sometimes it's still machines, it's still people behind the machines, so mistakes can happen, but you will be able to handle them. Then, as I mentioned in the beginning, we can test all the want, and for that solution, I also tested the container apps, I tested app services, I tested quite a lot of things, even Kubernetes I did test, but they have to see why you test all those things. You cannot just use a project as a playground. You really have to see why things work or why they don't work. And then, as I mentioned also in the beginning, of course, it's all about money. Money matters a lot, but what they're really interested to see is a return of investment. They want to see that their money is used wisely and it brings value to the company. And being honest and owning your mistakes and admitting that I'm sorry. Like I thought that this worked that way. Apparently, it was changed a few months ago. I wasn't aware of that. Nobody will kill you. Nobody will look you in a bad way. And last but not least, awareness creates confidence, and this is what they really, really want to buy from us. I hope you enjoyed my session. I really thank you for being part of it.
Dear Nico, we are impressed by your amazing presentation.
Thank you.
I have to tell you that your real story, we will keep it, and I will try to make the same. I told you from the beginning that we will do the same. I would like to express once again our immense appreciation for your presence here today. And I hope to see you soon in person.
Definitely. I will try to come to Greece as soon as possible.
Thank you. Thank you, Nico. We don't
Thanks
have any questions. Thank you, Nico. We will move quickly to the next slot. Thank you.
Bye.
Thanks a lot.
Bye.
Bye. Bye.